Kieran. I'm here to talk about subframe latency encoding. So I have a problem in that my users, broadcasters, they don't measure latency in seconds, milliseconds, or even frames. They measure latency in lines of delay. And just for reference, a line is approximately 40 microseconds. It's really small, and there's very specialist things that people do to measure this. But unlike, I think, most of the presentations here, I control the entirety of the stack, from capture to playback, electronics, firmware, drivers, user space, you name it, I control it. So this means I can do a lot of interesting things that most, if not all, software applications don't do at the moment, which is do encoding and decoding based off subframe capabilities, whereas applications like ffmpeg, for example, in the main work on waiting for a frame to arrive, processing the frame, then sending it out. So I can do some interesting things. So this is the kind of pipeline that we use. I've tried in Google Present to make it possible, but what I do is I wait for a chunk to arrive. That's approximately 16 to 32 lines of data. So that's in the red. I encode it quickly, send it over the network. About 5 to 10 milliseconds later, so I've added some buffering in to avoid, this is not a hardware system, it's not a real-time operating system, so there is a little bit of jitter involved. In green, I therefore then decode the frame, in green I decode the frame, and then orange, I present it. So this means I can have a really, really low latency on the order of lines. It does pose a number of technical problems though. Power saving is of the order of magnitude of hundreds of microseconds. That's a power saving. Using languages that have garbage collection, again, on the order of microseconds to milliseconds, I can't do any of that. So in ffmpeg, we've done this at the moment with VC2, formerly known as Dirac Pro, at high bit rates, 200 megabits. There's no current API for chunk-based encoding in ffmpeg. Oddly, and I'm not sure if anybody ever actually used this, there was an API for chunk-based decoding in ffmpeg. Unfortunately, unmaintained since it was not unit tested as an API call. So we're fixing that. So what we do is decode each null as it arrives, and therefore, when the last null arrives, the frame is essentially done. So that's stage one of doing this. And the next step is to use the draw horizontal band callback. So that basically is a callback that says, I have sliced data available now. And that's really good, because I can then render that data straight into my hardware immediately as soon as I get it. And also quite useful, because the data is fresh in cache. It's very useful. And the next major piece of work we'd like to do is get X264 to support subframe encoding. So actually doing prediction on these streams to get that 200 megabits down to 50 or 20. So I get an FAQ whenever people ask what I work on. How do you do X rate control? And the answer is quickly and naively, because there really isn't time to do anything.